Assalamualaikum and a very good day. So now we are going to learn the last part of week 9 video. This video actually should be learned last week, but because of this week just cover review topic of the metric, I bring this video to week 10. So in this video, you will learn how to plot roses. Let's start with general form of roses. Roses is given by the formula R equal to A cos n theta or R equal to A sin n theta. This formula will produce graph of a flower shape, that is, we call it as rose, where here A value should be greater than 0 and n is a positive integer. For these roses, it will have petals. When we plot, it will have petals, and the number of petals depends on the number of n. If our n here is odd number, so number of petals will be equal to n. But even number, so number of petals is equal to 2n. The length of the petal is given by magnitude of r, and each petal has the same length and equally spaced. That is, the angle between petals are equal. So class, for this concept, which is number of petals here depends on the number of n. Let's say I have here r equal to 3 cos 2 theta. So you can see this n is equal to 2, which is n is even number. When n equal to 2, our petals, the number of petals will be equal to 2 times n, which is times 2, which is 4. But if we have, for example, r equal to 3 sine 3 theta, in this case, our n is odd number. When n is odd number, our petals will be equal to n, which is equal to 3. What does it mean by petal? Petal actually it is like this leaf, which is, for example, if n is 3, you will have maybe 1, 2, 3 petals. But let's say, if for this example, maybe you will have here 1, 2, 3, 4 petals. So 1, 2, 3, 4 petals. For this case, this refers to the n, whether it is odd or even number. So class, generally, we will have this kind of shape for roses. When you have here r equal to a sine 2 theta, so this is a rose curve with four petals because here our n is 2. So we have learned previously when n is 2, it is even number, petals equal to 2 times n, which is, for this case, it is 4. And this one, because our n is 3, it is odd number, so our roses will have here 3 petals. And in this case, which is our n is 4, means that in this case, you will have here 2 times 4, means that we have 8 petals. And for the last one, a sine 5 theta. So in this case, our n is odd number, which is equal to 5, means that this is a rose curve with 5 petals. This is a general shape for sine and cos theta. If you see, cos always start with 0 degree. Okay, but for sine theta, it always start at this angle. It is not start with this at this 0 degree. This is for n equal to 2. We have here 4 petals, but for this cos, it start with the 0 angle. But for this one, it start with the 45, I think like something 45 degree, and so on. Let's go to this example 1. The question asks us to sketch the following polar curve. So we start here with A, r equal to 3 cos theta. How to solve for this? We have here 3 steps. The first step, we need to obtain the first distance petal. How to obtain this one? You can use this formula. So what does it mean by this formula? It is actually 360 degree. That is 1 unit circle divided by n. In our case, we have here our a equal to 3 and our n is 3. This a is given by this value, and then this one is n, because we know in general we have r equal to a cos n theta. So our A3 n is 3 means that to obtain the first distance petal, you have to divide a 360 degree with n. That is, our n here is 3. Means that I have here 360 degree divided by 3. So it is 120 degree. And then step number 2, we need to find the location of the first bond. How to find this location? It is to make our equation, which is r equal to a. What does it mean by this one? Our r is given by this equation and a is 3. So in this case, you have to write your 3 cos 3 theta. It is equal to a, so equal to 3. When I have this one, I can solve this equation for theta. Means that 3 cos 3 theta equal to 3. This one moved to this side, so I have cos 3 theta equal to 1. And then when I take here a cosine of this one, we got here 0 degree, means that our theta for this case equal to 0 degree. What does it mean by this one? It is actually the first bond, because we know the petal when we plot it is like this. So the first bond is given by 0 degree, means that this one is our first bond. Okay. And then number 3, we go to the size of petal, which is tangent line. Tangent line can be solved, can be obtained by using formula r equal to 0. Means that our equation, which is given by 3 cos 3 theta, we make it equal to 0. So we got this kind of equation. When we solve this one for 3 theta, you will got here a cosine 0. And then you can get, when you solve using calculator, this one equal to 90 degree. So our theta equal to 90 degree divided by 3, which is we got here 30 degree. What does it mean here? In this case, we know that we have here the first distance petal is 120 degree. The first location of the first bond is 0 degree, and the size of the petal is given by 30 degree. So what we have here, okay, number 1, the first distance petal is equal to 120 degree. Location for the first bond is 0 degree, and then our tangent line is equal to 30 degree. What does it mean? When I plot here, I will have my first distance petal, which is starting from the first bond. This is our the first bond 0 degree. This is 0 degree, 90 degree, 180 degree, 270 degree, and then it will back to 360 degree. So starting from the first point, you will have first distance petal. After this, your first distance petal is 120 degree, means that let's say somewhere here. And then you know that number of petal here n equal to 3. So petals will be equal to n, which is equal to 3 because n is odd number. So you will have here 3 petals. In this case, this is your first bond. This one will be your second bond, and you need another bond, which is you, because you have here 3 petals. So another bond means that 120 degree, we need to add here with 120 degree. So we will have here 240 degree for this one. So this is our third bond. And then based on this, we know that we have a tangent line 30 degree. So this petal will have a tangent line. Let's say this one is 30 degree. Here also 30 degree. This is a bond. So when we plot here, you will have this kind of petal. Okay, that will touch this tangent line. Same with here. In this case, you will have a tangent line 30 degree. So 90 plus 30, you will got this kind of, this is your tangent line. Okay, this is your tangent line for this bone. And then you will have another tangent line, let's say somewhere here, that is another 30 degree. 120 plus 30 degree. So here is 150 degree. Okay, so another petal will touch this tangent line, so will form this kind of shape. And then from here also you will have here, this is your third bone, means that from here you will have 30 degree. So this one is another tangent line for this bone. And then here you have 240 degree, means that somewhere here, for example, which is this one minus this one to 1 degree, because minus 30 degree is go to here, means that this is your third tangent line. When you plot, you will got this kind of. So here we start with 0 degree, and from this 0 degree you will have another one which is 120 degree. From this 120 degree you will have another bone which is 240 degree. And to plot this pattern, you need to know tangent line. So tangent line for every 30 degree of angle starting with this bone will give you tangent line, and your pattern will touch this tangent line. But what about this value? This value will take the R value, which is here, it is equal to 3. So this one also 3, this one also 3. Actually negative 3 because negative side. This is how we can plot pattern for R equal to 3 cos 3 theta. That's why based on this, we'll have here